Good morning children, I hope class 10 children are watching this video and I hope you must be doing well. As we have been doing some applications of trigonometry, exercise 9.1, already up to question number 12 we have completed and it was told to complete the exercise. I hope many of you must have completed. And up to question number 12 at least you must be very confident and you must be able to solve each and every question by yourself. And for this proper practice is required, I hope you must have done. Today in this class, we are going to see remaining questions, question number 13 to 16. So let's start. Here we have question number 13. As observed from the top of a 75-meter high lighthouse from the sea level, the angles of depression of two ships are 30 degree and 45 degree. If one ship is exactly behind the other on the same side of the lighthouse, find the distance between the two ships. Just you see how we will draw figure. As observed from the top of a 75-meter lighthouse. So suppose this is your lighthouse. And height of the lighthouse has been given, that is 75 meter. The angles of depression of two ships are 30 degree and 45 degree. Suppose at 2 points you have ships. Suppose this is one ship, this is another. Name it. Suppose A, B, C and D. Now angle of depression has been given. Angle of depression has been given 30 degree and 45 degree. So angle of depression from here, you see these two ships, this has been given. One angle is, this one angle is 30 degree and this angle has been given, this angle is 45 degree. So now you see this angle, you see 30 degree, this is exterior alternate interior angle of this angle A. So if this is 30 degree, this will be also 30 degree. And here if you have 45 degree, so this angle will be 45 degree. Now we'll solve question. What we need to find out, if one ship is exactly behind the other on the same side of the lighthouse, find the distance between the two ships. This distance you need to find out. AB is required to be found out. This we need to find out. So two triangles we will get, right angle triangle DCB and DCA. So first start with triangle DCB. Here we will write, suppose CD is the tower having height 75 meters. Now here you see two ships are there on the same line, at point A and B. 2 points are there at point A and point B. Now in triangle DCB, angle C is equal to 90 degree angle B is equal to 45 degree. DC has been given 75 meter, BC you need to find out, so this will be B and this will be D. It means tan 45 degree you will see. Tan 45 degree is equal to DC by BC. Tan 45 is 1, DC has been given 75 and divided by BC, and therefore BC will be 75 meter. This we have got. Now in triangle ACD, angle C is equal to 90 degree and angle A is equal to 30 degree. So here we will write tan 30 degree is equal to DC divided by AC. Tan 30 we know that is 1 by root 3 and that is equal to 75 and divided by AC can be written as AB plus BC. AB plus BC. So here you see AB plus BC, AB plus BC is equal to what you will get 75 root 3. 75 root 3. Now BC already we have got. BC is equal to 75. So AB plus 75 is equal to 75 root 3, or AB will be equal to 75 root 3 minus 75, or that will be 75 root 3 minus 1. So AB will be equal to 75 root 3 minus 1, or one thing can be done. Value can be put 1.732 and can be simplified. That is also possible. 75 into 1.732 minus 1 means 0.732. 75 into 0.732 you can write, and that will be your answer, or simply this also can be written answer. So AB is equal to this much meter. So distance, your answer you had to find out the distance between the two sheets. So you will write answer, hence the distance between the two sheets is equal to 75 into root 3 minus 1 meter, and this is your answer. So in this way this type of questions are required to be solved. Next question we will see. Question number 14. Here we have a 1.2 meter tall girl spots a balloon moving with the wind in a horizontal line at a height of 88.2 meters. Here you see small girl is there, height has been given, that is 1.2 meter. This is 1.2 meter height of the girl, and she has spotted one balloon, and that is having height 88.2 meter. The angle of elevation of the balloon from the eyes of the girl at any instant is 60 degrees. Suppose here it was there, at any instant that the angle of elevation from eye of that child is 60. Angle of elevation of that balloon from the eye of the child is 60 degrees. After some time, the angle of elevation reduces to 30 degrees. Just you see, balloon has been moved horizontally, and angle of elevation has become now 30 degrees. Find the distance travelled by the balloon during the interval. So you need to find out the distance travelled by the balloon here you see distance traveled by the balloon from here to here. Distance traveled by the balloon you need to find out. Here you see we will name it. Suppose you have A, B, C, D and E, and since DC and D are equal, so this is 88.2 meter. D is also 88.2 meter as DC we have. So first we will find out AB, this distance we will find out. So from triangle EBA we can find out this distance, and we will take this triangle DCA and we will find out AC, and we will subtract this distance so that we can get BC. So here we will write from the given figure in triangle ABE, in triangle ABE, angle B is equal to 90 degree, angle A is equal to 60 degree, and BE is equal to DC, and that is equal to 88.2 meter. Now here you see what is required to be seen, because this is the height of the from the ground has been given 88.2 meter. So this point, if we will take this point B and this point A, B, C we have taken. So if this, from this point we are taking, from the eye of that child will be 88.2 meter minus 1.2 meter, and that will be equal to 87 meter. This will be 87 meter. So height from the ground has been given. Height from the ground is 88.2 meter. 88.2 meter. But from here, from this point, height will be 87 meter. This we need to know. So this has been given. Now tan 60 degree will be equal to BE divided by AB. So tan 60 we know that is root 3. BE has been given. BE is 87 divided by AB. AB we need to find out, and therefore AB will be 87 by root 3. So AB we have got. Now in triangle DCB or BCD, in triangle BCD, angle C is equal to 90 degree, we will take this triangle. We will take triangle ACD. We take a triangle ACD, angle C is equal to 90 degree, angle A is equal to 30 degree. So tan 30 degree will be equal to CD divided by AC. Tan 30 we know that is 1 by root 3. And CD has been given, that is 87, divided by AC. AC we can write AB plus BC. AB plus BC. Or AB plus BC will be equal to 87 root 3. Or here you see AB already we have found out. That is 87 by root 3 plus BC is equal to 87 root 3. And then here you see BC will be equal to, or BC will be equal to 87 root 3 minus 87 by root 3. Here you see LCM will be root 3. Root 3 into root 3 is equal to 3. 3 7 is 21. 2 you have. 3 8 is 24 and 2 26 minus 87. You subtract this, what we will get? 11 minus 7 is equal to 4. 15 minus 8 is equal to 7 and this is 1 divided by root 3. This you rationalize, what you will get? Root 3 into root 3. So you will get 174 root 3 divided by 3. You divide this, 3 1 is 3, 3 1 is 3, 3 5 is 15 and 3 8 is 24. So you will get 58 root 3 meter. So your find the distance traveled by the balloon during the interval. What you have got? BC. Distance traveled. This distance has been traveled by the balloon. So BC you had to find out. So during the interval, the distance traveled by the balloon during the interval will be 58 root 3 and this will be your answer. So in proper way, as answer we write in that way, you need to write down answer. So this is your answer. Next we have question number 15. A straight highway leads to the foot of a tower. A man standing at the top of the tower observes a car at an angle of depression of 30 degrees which is approaching the foot of the tower with a uniform speed. 6 seconds later, the angle of depression of the car is found to be 60 degrees. Find the time taken by the car to reach the foot of the tower from this point. Here you see, a straight highway leads to the foot of a tower. Suppose this is your tower and this is your highway. So towards foot of the tower, road is passing through. A man standing at the top of the tower observes a car at an angle of depression of 30 degrees. Suppose from here, top of the tower, angle of depression at here is 30 degrees. 6 seconds later, so here car was spotted and then 6 seconds distance traveled here, this distance in 6 seconds. 6 seconds. 6 seconds later, the angle of depression of the car is found to be 60 degrees. So here it is now 60 degrees. This angle will become 60 degrees. Find the time taken by the car to reach the foot of the tower from this point. So this time you need to find out. How much time it took from this point to this point. So first you name it. Suppose this is A, B, C and D you have. So since again alternate interior angle it is, so this will be 30 degree and this will be 60 degree. So here you see how we solve. Suppose in the drawn figure, AB is the tower. AB is the tower. Angle C is equal to 60 degree and angle D is equal to 30 degree. Now from triangle ABD you see, from triangle ABD, angle B is equal to 90 degree, angle D is equal to 30 degree. Therefore, tan 30 degree is equal to AB by BD. And tan 30 is equal to 1 by root 3, and that is equal to AB by BD. BD can be written as DC plus BC. DC plus BC, or DC plus BC will be AB by root 3, or simply you find out root 3, AB you find out, AB you write down, AB will be equal to DC plus BC by root 3. Now, from triangle ABC, this triangle is a angle B is equal to 90 degree and angle C is equal to 60 degree. So tan 60 degree will be equal to AB by BC. So AB tan 60 is equal to root 3 and AB by BC, or AB will be equal to BC root 3. Now here you see AB is equal to DC plus BC by root 3, AB is equal to BC root 3. So this you suppose first and this you suppose second. So from first and second, DC plus BC by root 3 is equal to BC root 3. So we will write BC root 3 is equal to BC root 3 is equal to DC plus BC by root 3. DC plus BC by root 3, or BC, we can write BC into root 3, BC root 3 into root 3 is equal to 3BC will be equal to DC plus BC, or BC 3BC minus BC is equal to DC, or 2BC is equal to DC, or 2, here you see what we had to find out. We had to find out BC. DC has been given 6 seconds. So 2BC is equal to, DC has been given 6 seconds. So BC will take how much time? 6 seconds divided by 2, and that is equal to 3 seconds. So BC will take this distance, BC what has been given, that will be 3 seconds. So we will write hence, what we had to write, find the time taken by the car to reach the foot of the tower from this point. Time taken by the car from to the foot of the tower. Foot of the tower will be 3 seconds, and this will be your answer. Here you see what we have got. Here we have got 2BC is equal to DC. So if DC has been given 6 seconds, so in 6 seconds it takes, suppose DC is a distance, this is not the time as we have put now. So here we can write, since DC is equal to 2BC, or BC is equal to half of DC. Therefore, we can write, if it is taking, this distance is taking 6 seconds. This is not the value of DC. Don't be confused. This is not the value of DC. Time it is taking to cover this distance. We will write, since time taken to cover the distance DC is equal to 6 seconds. Therefore, time taken for the distance BC will be half of DC, and therefore this will be your answer, 3 seconds. So don't be confused, the value has not been put, 6. Then we have question number 16. The angles of elevation of the top of a tower from the 2 points at a distance of 4 meter and 9 meter from the base of the tower and in the same straight line with it are complementary. Prove that the height of the tower is 6 meters. Suppose you have, this is the tower and that is 6 meters. The angles of elevation of the top of a tower from 2 points at a distance of 4 meter and 9 meter. Suppose you need to prove this 6 meter. You have 4 meter and 9 meter. This you have, suppose 4 meter and this you have 9 meter. Or the same side also it may be. So angles are complementary. It means suppose if one angle is x degree, the other is 90 minus x. The other will be 90 minus x, the complementary angle. Name it. Suppose A, B, C and D you have. Now in triangle ABC, those things you can write. AB is the tower, 2 points are there, C and D. So those things as we write, that if you want can be written. And then you can start in triangle ABC. Angle B is equal to 90 degree. Angle C is equal to x degree. So and BC is equal to 4 meter. So tan x degree will be equal to AB by BC. AB by BC, or tan x degree will be AB by 4, or AB is equal to 4 tan x degree. Now in triangle ABD you see, in triangle ABD, in triangle ABD, angle B is equal to 90 degree, angle D is equal to 90 minus x. Now tan 90 minus x is equal to, tan 90 minus x is equal to AB by BD, or tan 90 minus theta is equal to cot theta. Cot x is equal to AB by BD. BD is equal to 9. Now here you see what we will do. You need to remember this, how it to be done. Here we have AB is equal to 9 cot x degree. 9 cot x degree. Now here we have got AB is equal to 4 tan x degree. AB is equal to 9 cot x degree. So from first and second, just you multiply this. First and second. AB into AB will become AB square, and that is equal to 4 into 9, 36, tan into cot, here you write tan x into cot x. So AB will be equal to tan x and cot x will be cancelled, 36 into 1 and under root. This will be under root 36 into 1. So this will be plus minus 6 meter. What you have to find out? Prove that the height of the tower is 6 meter. So therefore, height of the tower cannot be negative. Tower will be 6 meter, and this will be your answer. So in this way we need to do. So this thing you need to remember. Here one more thing can be done. This figure could be drawn in this way also. Suppose this is your tower and 2 points you can take same side. And in this case this length will be 9 meter and this length will be 4 meter. So either in this way also you draw, because this side has not been given, only they are on the same line. Side has not been given, so any figure can be drawn. But if you are solving this, lastly you will get 6 meter, and this you had to prove, and you have proved. So in this way we have completed our exercise 9.1, and each and every questions have been solved. So I don't think any further discussion is required regarding height and distance of trigonometry. What you need to do, practice and practice, again and again practice is required. So from this exercise already each and every questions have been solved. You go through properly, learn properly, solve by yourself. From R.S. Agrawal many questions have been given in example as well as in exercise. Both the things you need to do. It is not as in example, if something has been given that is not for you, that is for you. Each and every example you must know, each and every question from the same exercise you must know. So you solve that, practice that properly, so that you must not leave a single question from this chapter. So I hope for the best. Next day we'll see next topic. Until then, thank you.